started. Just again, as a comment, so due tomorrow on Wednesday, there's section 4.1 and 4.3. And then don't forget to get that exam scheduled. They send me an email, so I know that you've done it. And you need to get that done by Thursday. It has to be 72 hours ahead. And if you don't get it scheduled 72 hours ahead, you pay the late fee. So any questions on the linear applications and the linear functions from yesterday? I didn't look to see if anybody had done the homework yet, so I'm assuming it's going to go okay. We skipped section 4.2 again. It belongs in a statistics class. If we actually had more time, we would do it because I think it's something that's applicable, but we don't have time, so it gets cut. What we're going to talk about today are the section 4.3, specifically quadratic functions. Now, we've already worked with some quadratic functions, so just a reminder of what a quadratic function is. So that would be something along the line of f of x is equal to ax squared plus bx plus c. So that's it, technically considered the standard form. I wouldn't get too hung up on the words though. The key is that you see an x squared. So we need an x squared term. So the largest exponent you can see is a positive 2. You can't have any negative exponents, no fractional exponents. It's an x squared. We also know some important things about it already. So if we had it in this form, so f of x equals a times the quantity x minus h squared plus k. So these are both quadratic functions. They're just written in two different forms. This form is what I refer to as the vertex form, and you'll see why in just a second. We're going to use the idea of transformations to graph today. So we know that the A that is out in front tells us some important information. First of all, if it's positive, we know this thing's going to open up. If it's negative, we know it's going to open down because it's been reflected. So if A is positive, it opens up. And it, meaning the U shape, because we know these are parabolas. If A is negative, we know it's going to open down, because that would be a reflection across the x-axis. A also tells us the width that should make sense to us because we talked about that A out in front being a vertical stretch. So if A is a whole number, it's a vertical stretch. If A is a fraction less than 1, like 1/2 or 1/3, then you're going to have this compression in the vertical direction. So it tells us the width of it, tells us whether it's narrow or wide. This is really hard to gauge for us, so, but just as we know that. The other thing we know from this form is we know that the vertex is at h, k. So remember that if it's on the inside and it's negative, you would move to the right, which is why that's a positive h. The k that's afterwards is moving it up or down. So in this case, because I wrote a plus k, we know that that is moving it up. That vertex represents the maximum or the minimum. And that all depends on whether it opens up or down. So the vertex tells us about the maximum or the minimum, depending on whether it opens down, up or down. And then I kind of want to get on the board just a quickie kind of graph of what we're talking about. So we know that we'll have a point over here at h, k, and I drew it in quadrant 1 because at this point I'm calling h at k positive. It's not going to always be in quadrant 1. And because we have a over here, we'll assume it's positive. It looks something like that. So we already knew all this. This was nothing new to us. So let's go graph one using transformations just to make sure everybody's on board with that. Can I erase?
Yes.
Okay. So let's graph f of x is equal to -2 times x plus 1 quantity squared minus 3. So f of x equals a negative 2 times x plus 1 quantity squared minus 3. This is a good review because transformations are on the exam this week. So, okay, let's take them a little step at a time. We've got a negative out in front, and it's a negative 2. So does that tell me it opens up or does it open down?
Down.
Good. So we know it opens down. Let's go find the vertex. Okay, so the vertex is coming from the information that's on the inside of the square and what's being added or subtracted at the end of the square. So because this is a plus 1, we know that when we pull it out of the parentheses, we do the opposite of what it says. So we're going to call that a negative 1. When it's outside the parentheses, you do exactly what it says. So that's a negative 3. So right now we know a lot. Now the 2 that's out in front tells me that it's somewhat narrow. Take that with a grain of salt. So we're going to go over here to negative 1, negative 3. And then we're going to draw one that opens down and is fairly narrow. So at this point, that's what we've got. So notice that this is just a sketch using transformations. In a few minutes, we're going to be a little bit more nitpicky about that width. But in order to do that, we need more information to be able to do that. We can also tell a couple of other things about this immediately, though. What about its domain? So again, domain is everything from left to right on that graph. You've got a lot of ways of doing this. You can look at your picture. Those arrows that are on the ends of the parabola are telling you that it's going out in both directions. So we know the domain would go from negative infinity to infinity. The range, which is the bottom of the graph to the top of the graph. So where's the bottom of our graph?
Negative infinity.
Yep, and where's our top of our graph? We're going to come back and pick up the y coordinate of that vertex, which is negative 3. And because it's a point, we'll put a closed circle. So again, this is the y coordinate of the vertex. So that's nice. Okay, the other thing we can talk about is increasing and decreasing. Again, this ties in nicely to what we did in the last chapter. So the graph is increasing what on the left side and decreasing on the right side. We're walking uphill on this side. So that would be from negative infinity to negative 1. And it's decreasing from negative 1 to infinity. You notice this time we picked up the x coordinate of the vertex. That's why the vertex is so important. So this is the x coordinate. So if I'm just going to sketch it, all I really need is that vertex and whether it opens up or down and whether to make it narrow or wide. Comments or questions? You're saying, why is this in its own section? We've already done all of this. Well, what's going to happen is it's not going to be in this vertex form. So again, what I call the vertex form, f of x equals a times x minus h squared plus k. So how am I going to graph something that looks like instead f of x equals 2 x squared plus 8x plus 5. So this goes back to standard form. So if you were going to use the quadratic formula, this is the form you would want it to be in. Okay. So the problem is we need to put this into the other form. So to find the vertex, we have two methods. And because you're doing this online, I'm not even going to really walk through one of them because I don't think you'll use it. So method 1 is to complete the square. If you need that method in your future, you'll pick it up in pre-calc, so I'm not too worried about it. It is also in your textbook if you want to go look at it. We're going to use method 2 because it's easier on us, is to use a formula. Well, that sounds like a much easier method. Okay, so we're going to pick up method 2. So again, what our goal is to take this beginning quadratic and make it look like this so we can find the vertex. So to do that, we're going to go find the x-coordinate. To find the x-coordinate of the vertex, we do a negative b over 2 times a. So a negative b over 2 times a. And literally, when I talk to students 5 years later that I had in this class and asked them, you know, so do you remember anything that we talked about? This seems to be the one thing that they can remember no matter what. So that's nice, I guess. So for us, again, remember that this is a quadratic function sitting up here. So when I talk about the b's and the a is that 2, the b is our 8, and c would be 5 if I needed it, but that's where the a and the b are coming from. So they're coming from ax squared plus bx plus c. So for us, our x coordinates, so we're going to say x is equal to the opposite of b. Well, b is 8, its opposite is a negative 8, over 2 times a, and a is also 2. So I have a negative 8 over 2 times 2. Watch your order of operations. That's a negative 8 over 4, which gives me a negative 2. So right now, I know our vertex is at negative 2 comma something. So now I have to go figure out where that something is. So I have to go find the y-coordinate. So to find the y-coordinate, we're going to plug our answer back into the function. So plug the answer into f of x. So this should make sense. We talked about this. If you know the x-coordinate or the input, in order to get the output, you just plug it in. So what we're going to do is go find what f of negative 2 is. So that would be 2 times negative 2 squared plus 8 times a negative 2 plus 5. So again, I'm going back to this and plugging in that negative 2. Be very careful here. This is where you tend to make sloppy arithmetic errors. You must square before you do anything else. So this would be 2 times the negative 2 squared, which is 4. The 8 times the negative 2 is going to be a minus 16 plus 5. So 2 times 4 is 8, minus 16 plus 5. So 8 minus 16 is a negative 8 plus 5 gives me a negative 3. So I end up with negative 2 comma negative 3. So we now know that the y-coordinate of our vertex in this particular problem is a negative 3. So that's going to come right there. Okay. And that's how I can find my vertex. So again, we could complete the square, but it's uglier for us. It's not as easy. We did do that when we did circles, so it's not like we haven't done it. But for us, it's just a lot easier to go use this vertex formula. Comments or questions about that?
I'm okay.
Okay. So I need a bunch of stuff to keep. So negative 2, negative 3. I'm going to go way back. So what you will note on the homework is that these problems have multiple parts to them because they want to know a lot of information about it. So whoops, just drop that one. Go to the spare eraser. Okay. So what we want to do is we're going to graph. So these are our directions on our problem. We're going to graph, and we're going to do that by finding the vertex, intercepts, and something called the axis of symmetry, which we've not talked about, but we will. So the vertex, the intercepts, and the axis of symmetry. We're then going to find the domain and range. Then finally, the increasing and decreasing intervals. So increasing and decreasing intervals. Okay, so that's what we need to do for this function. Okay, well, we've already done the vertex. So we already know that our vertex is at -2, -3. We already did that part. So that was the harder part. Okay, but they also want me to come in and find the intercepts and the axis of symmetry. So let's go find the y-intercept because it's the quickest one to find. So the y-intercept, if all the x's are zeros, is going to be a 5. So that's 0, 5. So notice that was really easy to pick when it's in this standard form. If it were in the vertex form, it would be a little bit harder to find. I'd actually literally have to figure out when I plug a 0, what h squared is, times the a, and then add the k. Okay, the x-intercepts for this one are ugly, and I picked it on purpose. To find the x-intercepts, we know we have to set the function equal to 0. So we check to see if it factors first. 2 times 5 is 10. There are no factors of 10 that add to 8. So I'm going to have to go to the quadratic formula. So we're going to use the quadratic formula. Okay. So x is equal to the opposite of b, plus or minus the square root of b squared. That would be 8 squared minus 4 times a, which is 2, times c, which is 5. All over 2 times a, which is 2. That's -8 plus or minus the square root of 64 minus 2 times 5 is 10 times 4 is 40. All over 4. So that's a -8 plus or minus the square root of 24 over 4. Square root of 24, so 24 is what, 4 times 6? So that would be the square root of 4, which is 2. I'm getting ahead of myself. So the square root of 4 is 2. I'm going to leave the 6 on the inside and put that all over 4. Now everything reduces by 2, so the 8, the 2, and the 4 can all get divided by 2. So I end up with -4 plus or minus the square root of 6 over 2. Those are my x-intercepts. So I'm going to say comma 0 and put them in parentheses. Those are ugly, and I expect them to be ugly. They're not going to be nice numbers in general. You're going to get some pretty ugly looking stuff. Okay, so that's our x-intercepts. I'm going to write that up here just so I've got them. So one time my board is definitely not big enough. So -4 plus or minus the square root of 6 all over 2, comma 0. Okay. Okay, well, believe it or not, that's going to give me a fairly decent picture of what's going on. And right now you're probably starting to think about how the heck are we going to graph that? Just have some patience here. So we're over here at -2, -3, and that's our vertex. We know that we're going to cross the y-intercept up here at 5, which is up here. Okay, so what I like to do, especially because I usually work without a calculator, I'm going to recognize that a parabola has this idea of symmetry. So if my y-intercept is over here and I'm 2 units away from the vertex in terms of the x direction, then that means over here on this side, I'll have another point that is symmetrical to it. So I know that this point is over here at 0, 5. I know that this is at -2, -3. So since I was 2 units away on this side, I'm going to be 2 units away. So this is over here at -4, 5. That's enough to give me a pretty picture. So I'm going to start at my vertex and head up. Start at my vertex and head up. So it gives me the width without having to worry about what those decimals are. So this is some decimal, and it's right there, and it's right there. So what they are, I don't know. You can go to your calculator and figure it out, but I just find this easier for me. Okay, so we did the vertex, the intercepts, the axis of symmetry. is literally, you don't have to draw it in. I'm only drawing it in to help us understand what they're talking about. It literally is going through, sorry, that's not a very straight line, the center of our parabola, which is that vertex. It's the fold line for our vertex. Boy, I didn't do a very good job of drawing that. That should be on either side of that. So hopefully yours is a little better than mine. So as an equation, the axis of symmetry is a vertical line that the graph folds across. So because it's a vertical line, we'll say x equal to, and we're going to pick up the x coordinate of the vertex. So x equals a -2. And that's your axis of symmetry. So we did all of part A. We graphed it, we found the vertex, we found all the intercepts, and we have our axis of symmetry. Our domain is going to be -infinity to infinity. That will be the same domain for every single parabola you ever graph in our class. They are all functions, so they're all going to open up or down. They'll use all real numbers. You know that for multiple reasons. You know that because, first of all, the picture tells us that. Also, if we take a look back at the function, it doesn't have a radical, and it doesn't have x in the denominator. So all of that is telling you that, yep, we're good to go. Our range, in this case, is the bottom of the graph, which starts at -3 and goes up to infinity. Because -3 is part of it, we'll put a bracket on it. Increasing and decreasing, so this one's kind of flipped of our first one. It is decreasing on this side and increasing on this side. So actually, I'm going to write the decreasing first. I tend to write them in numerical order. So it's decreasing from -infinity to -2, and it's increasing from -2 to infinity. So again, the range picks up the y values, but those increasing and decreasing are always the x values. So, okay, and that's everything we need on that one. So as a word of caution, be careful. You don't have to have x-intercepts. If we go back and take a look at the one that I kind of quickly graphed to begin with, where I put it over here in this quadrant and it moved up, notice that this has no x-intercepts. It doesn't have to cross the x-axis. It will cross the y-axis eventually, right? How would you know this? Well, when you use the quadratic formula, you end up with the square root of a negative number, which takes us into imaginary solutions, which tells us it has no x-intercepts. So, okay, let's backtrack, do another one really quickly that's a little bit shorter to do, because this one was kind of long. So we'd rather have one that's a little bit shorter in your notes also. Is everybody good with this one? They're long. So that's why I think you only have 3 full-blown problems to do, because they are long. Moving on. Same directions. So I want to graph my parabola. And to do that, I want to find all of that information. So this time we'll start off with one that's actually a little bit friendlier to do. So let's do g of x is equal to -x squared minus 6x. So -x squared minus 6x. So again, it's in standard form. It's not in our vertex form. What we are going to note right off the bat is that negative out in front. So that tells me that this graph opens down, which is important. So we know that we'll have a maximum when we get there. Okay, let's go find the vertex first. So we'll do -b over 2a, and that gives us our x coordinate. Sorry, I don't want to write that. So vertex, to get the x, we do -b over 2a. So that's the opposite of the -6 all over 2 times the -1. And again, be careful with your signs because the signs will get confusing. So in this case, I see 3 negative signs, so I know my final answer is negative, and 6 divided by 2 gives me a 3. So the x coordinate of the vertex is a -3. Now we need to find the y coordinate, so we're just going to plug that back in and find g of -3. So I have the opposite of a -3 squared minus 6 times a -3. Order of operations say do that squaring first. So -3 squared gives me a 9, so I now have the opposite of 9. So again, I squared it, made it positive, but the negative out in front turns it right back into a negative. -6 minus 3 is a positive 18. plus 18. And that's going to give us a positive 9. So we now know our vertex is at -3, 9. Let's go find our intercepts, the y-intercept. Well, we replace all the x's with zeros. So g of 0 would be 0, because the first term would be 0, second term would be 0. So the y-intercept is at 0. That's the origin. That's kind of nice. 0, 0. X-intercepts next. Same way we've always found them. We set the function equal to 0. Well, I'm going to factor this one. You could go to the quadratic formula again, but factoring is always quicker. So what I'm actually going to do is pull a negative x out. That's going to leave me with a positive x plus 6 equal to 0. So when I set the negative x to 0, I'll get x equals 0. When I set x plus 6 to 0, I'll get x equals a negative 6. So I have 2 x-intercepts, which I expect. I don't have to have 2. It could sit directly on the x-axis. In that case, it would only have 1. An argument with my 15-year-old when he was graphing a parabola at the end of his last school year about how it can only have 1. So don't worry, it can. Okay, 0, 0, and we said negative 6, 0. So I'm not surprised if the y-intercept was at the origin that one of the x-intercepts is also at the origin. That makes sense. Okay, at that point, I've got all the information. I need to go graph it. One of the things I'd like to do, and I forgot to do this on the other one, is what we now know is that this is actually equal to, in vertex form, a -1 times x, and now I'm going to pick up that vertex, plus 3 quantity squared, and then plus 9. Okay, so I picked up the coordinates of the vertex and put them back into that a times x minus h squared plus k, so that I can see that these are equivalent ones, but it's just so much easier to pull the information off of this. This -1 that's sitting out in front is coming from this, so that negative is that -1. So on the previous example, we had a 2 out in front. So if I'd gone to write that in the vertex form, I would have put a 2 right there. So whatever A is, it's the same in both places, no matter which form you're using. So in case they ask you to write it in that form, you can do it. Okay, let's go graph it. So we've got -3, positive 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, oops, almost did the same thing again. Don't do that. -3, positive 9. Okay, I know it's going to go through the origin, and then it's also going to cross over here at -6. So that'll give us a fairly nice looking parabola, something like that. So where's my axis of symmetry this time? So again, it's always vertical because that's what we're folding around. So our axis of symmetry would be x equals -3. And again, that's the x coordinate of the vertex giving us that axis of symmetry. I don't know that it really helps us in terms of the picture, but it's just nice type symmetry. And again, domain, all real numbers, very easy because it's the same for all of them. Okay, what's our range this time? I've been doing all the talking. What's my range?
9.
Correct. So we're going to start at -infinity and end at 9 because it's going from the bottom to the top. So -infinity to 9 with a bracket. Increasing and decreasing. So where is it increasing?
Infinity to 9.
Yep. So -infinity, but not to the 9. You have to pick up the x coordinate of the vertex, which is -3. So use the y coordinate for the range, but the x coordinate for the increasing and decreasing. And then it will be decreasing from -3 to infinity. Yay! Okay, we graphed 2 of them. I think that's enough. There's a couple of other questions at the end of the homework, so let's address those guys. Any problems graphing them? Really, that's all that's in this section is just how to graph the parabolas. So Okay, our next problem, we're going to do what I call the go backward problem. So in other words, starting with the picture or information about the picture, can you write the function? So the graph of a parabola has vertex at 1, 4, and passes through the point -1, -8, -1, -8. They want us to find the quadratic function. So that's really sloppy. This is why I like a chalkboard. I can write neater on a chalkboard. Okay, so what they gave me is both the vertex and a second point. So to write the equation of a parabola, I need basically the vertex and a second point, which is exactly what they gave us. We don't need to graph it. I'm just going to graph it to help understand what's going on. You don't need to graph it on your homework. So there's the point 1, 4. That's our vertex. It passes through -1, -8. So it's doing this. So here's our -1, -8, and this is our point up here at 1, 4. So on your homework, what they're going to do is they may give it to you in writing, in words as a sentence, or they may give you the picture. Okay, well, what we're going to do is we're going to use that vertex form because it is just so much friendlier. Okay, so we're going to use that form, and then at the end, we'll switch it into standard form. Well, we already know the vertex, so we already know what h and k are. So we know that f of x is equal to a times x minus 1 squared plus 4. And again, all I'm doing is picking up my vertex. When I bring the 1 in, notice I'm switching its sign back, and the 4 stays the same. So on the inside, you switch signs. On the outside, you leave it alone. Okay, but we need a. So to find a, we're going to use the second point. So we'll use the other point to find a. So in other words, we know that it also goes to the point -1, -8. So the output is -8. The input is -1. So I'm going to replace the x with the -1. I'm going to replace the f of x or the y with the -8. Again, follow your order of operations. This is a place where for some reason you guys just do some goofy stuff. So we have -8 equals a. This is going to give me a -2 on the inside of the parentheses, which I'm going to have to square. So -2 squared is 4 times a plus 4. Whatever you do, do not combine that 4 with that set of parentheses. It does not belong there. Okay, well, let's go ahead and solve this for a. So we'll move the 4 over. That gives me a -12 equals 4 times a, and then we'll divide by 4. So a equals a -3. So that backs up what we think is going on. We know that that makes it open it down, and it's fairly narrow. So then the answer is f of x is equal to -3 times x minus 1 quantity squared plus 4. Now, if we were in class and I was collecting paper homework, this is what I would want you to write as your answer. I have a feeling that MyLab Math is going to want you to expand that. So let's go ahead and take a few seconds to FOIL this out. So x minus 1 times x minus 1, x squared plus, sorry, x squared minus plus 1, and then plus 4. That's -3x squared plus 6x minus 3 plus 4. So I distributed my 3 in, and then I'll combine the last term. So -3x squared, excuse me, plus 6x plus 1. So this again would be what I call vertex form. This would be standard form. So just depends on what they want on that homework. So you're going to have 1 or 2 of those. Sorry, I got kind of low on the board. And then the homework ends with questions that are like this. So I want to determine without graphing. Whether f of x equals 2x squared plus 12x has a maximum or minimum value, and then find that value. So has a max or min value and find the value. So this is what I call a big picture kind of question. So I want to know whether or not that quadratic function has a maximum or minimum value, and then what that value is. This leads us into tomorrow's lecture. Tomorrow's lecture is all about application problems that are quadratics. So it's a good lead into that. I will mail those notes out later today, so you'll definitely need them because they're all word problems. Okay, well, what do we know? Well, we've got f of x equals 2x squared plus 12x minus 3. So does this particular quadratic open up or does it open down?
Up.
Yep, and that's this 2 out in front. So because that's a positive, we know that it opens up. So in my brain, I'm doing this, and if it opens up, then doesn't it have a minimum? Okay, so to answer the first question, determine without graphing whether it has a maximum or minimum. This one has a minimum value because it opens up. But now they want me to go find that. Okay, so that's the vertex. So this happens at the vertex, Well, we know how to do that. That's that magic negative b over 2a. So that would be a negative 12 over 2 times 2. So negative 12 divided by 4 gives me a negative 3. Wow, I've had a lot of negative 3s in all my examples. That does not always happen, believe me. Okay, well, that's the x-coordinate of the vertex. That x-coordinate doesn't tell me anything in terms of that being the largest or the smallest y value. So you have to plug that back in. So we're going to do f of negative 3. And that'll be our final answer. So again, order of operations, negative 3 squared is 9. So I have 2 times 9. 12 times 3 is a negative 36. Okay, and then minus 3. Oh, yeah, we're okay. Sorry. My mind was way ahead of my writing. So I have 18 minus 36 minus 3. What you should always note is that this number and this number, this is always half of this number because the 1/2 is sitting in our formula as 1 over 2 right there. So it should always be half. So 18 minus 36 is a negative 18. And a negative 18 minus 3 is a negative 21. Okay. Now that's the y coordinate of the vertex. And that's the answer to what the maximum or minimum value is. So we're going to say that the minimum value is negative 21. It's not a point. It's a single number, and it represents the smallest y value achievable on that picture. So the minimum value is that negative 21. Okay. And that's everything that's in that section. Anybody have any questions?
I'm okay.
We're good?
Good. Yeah.
Yay! Okay, so tomorrow's kind of important because we're going to do those word problems. So we're going to springboard off this idea of that graph and the maximum and minimums and do applications. So have a great day. Enjoy it. Go get some sunshine.
You too.
Bye-bye.
Bye.